Okay, here we go. So first of all, review is 1/15/2020. So find all 6 trig ratios. So we know what we're looking for is sine of theta, cosine of theta. We're looking for tangent of theta. We're looking for cosecant of theta, secant of theta, and cotangent of theta. Okay?
Can you move that over just reading?
I sure can. I don't need to write down what they are because they're up there. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? So that we know that's up there, okay? But what we don't know is the hypotenuse. So we're going to find the hypotenuse first. So the hypotenuse from Pythagoras' theorem is just simply going to be a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared, right? Just going to use Pythagoras' theorem. 25 plus 144 equals c squared. Yep. 169 equals c squared. Square root of that is 13. So I'm going to put my 13 on my hypotenuse. And now I have my opposite. I have my adjacent and my hypotenuse. So I'm just going to follow for sine, cosine, and tangent what's on the board. Sine is opposite hypotenuse, which is 5/13. Cosine is adjacent over hypotenuse, which is 12/13. And tangent, which is opposite adjacent, which is 5/12. Now, cosecant, secant, and cotangent are just the reciprocals. So 13 over 5, 13 over 12, and 12 over 5. And you guys can do this. We've been doing this for a good month or more, right? And you did this in geometry too. So this should be a super easy one for you, okay? Okay, number 2. All right, I've got a couple of ways to do it, but since it's a right triangle, I'm going to set it up using the right triangle trig. You could use the law of sines, but I'm not. I'm going to use right triangle trig, okay? So if I want to find x, that's my opposite. 10 is my hypotenuse. So I'm going to set up my opposite hypotenuse is my opposite hypotenuse. I look up on the board is sine. So I'm going to set up, this way. Yeah, so I'm going to set up sine of 49 degrees, because that's my theta, is equal to my x over my 10. That's just going using that sine theta. Theta is my angle, which is 49, equals my x, which is my opposite for hypotenuse. Now we got to make sure we're in degree mode. So make sure you're in degree mode. Okay, degree mode. Check your calculator, because if you're in radian mode, you're going to get it. You're going to do the right problem and get it wrong. Okay. So I'm just going to multiply up the 10 then, and I'm going to go 10 times the sine of 49, and that's the value of x. So I'm going to do that. Okay, just going to go 10 sine 49, and I get an answer about 7.5. Oh, we'll share because you got a good one. Okay, I'll use the old one. Okay, is that good? Okay, 3. I need to find the angle. So I do know that I'm going to have to push the inverse button, right? I'm going to have to push my inverse, or like Cameron says, it's the blue button, the second button, right? I know if I need to find an angle, I have to hit the inverse button. So let's set it up. That's my opposite. That's my adjacent side. I don't know the hypotenuse, but I don't need to. Opposite over adjacent is tangent. So it says tangent of theta, but tangent of x degrees, because that's my angle, right? Tangent of theta, but x is my angle, is equal to my opposite, which is 10 over my adjacent, which is 12. We're looking for the angle, so I'm going to do the inverse of that. So I'm going to go tangent inverse of my 10 over my 12. I'm just going to use my calculator, and I'm going to go tan inverse of my 10 divided by my 12, and I get an answer about 39.8 degrees. That makes sense. So if you get weird answers, check your mode, okay? But 39.8 degrees. How am I doing?
Fire.
Beautiful.
You guys can do this. Okay, now I get to 4. I no longer have a right triangle. What I have is opposites, though. So I've got my opposite here, opposites, opposite, opposite. So if I have my opposites, we use the law of sines. So I'm going to set up x over the sine of 74 equals my 10 over my sine of 80, right? And I'm just going to multiply up sine of 74. So I'm just going to multiply in my calculator. We're going to set it up as simply my 10 times the sine of 74, close your parentheses, divided by sine of 80, and I get an answer of about 9.76. 9.7.
Back up on the board, Mr. Trig?
Am I going to do what?
Are you gonna write these back up on the board?
No, they're in your notes, right? Yeah.
Funny thing, Mr. Davies.
Hope so. Okay.
Def.
13. Okay.
Do your notes.
I don't have a pair of opposites. There's no opposites because I got 50, so I can use the law of cosines, and I'll say it and then I'll write it. I'll say it. It is opposite squared equals adjacent squared plus adjacent squared minus 2 times adjacent times the cosine of my angle. So let's write that down. X squared, that's my opposite squared, equals my adjacent squared, 13 squared, plus my adjacent squared, which is my 14 squared, minus my 2 times my adjacent times my other adjacent times the cosine of my angle, okay? I'm going to put all of that in my calculator, okay? And then I'll square root that because it's x squared. Okay, so I'm going to put all of that in my calculator. I'm just going to go 13 squared plus 14 squared minus 2 times 13 times 14 times the cosine of 50. And I get about 131. But I'm going to take the square root of that, right? Because it's x squared. So square root of that answer, I get about 11.44, 11.45.
Is part of the equation.
No, it's 2.
2 is in the equation. 2 is always there in the equation. That's what you guys were talking about?
Yeah.
Yeah, 2 is always there as part of the equation, okay? Okay, how am I doing? Yeah.
So I was wondering with that -2 there, you wouldn't have parentheses around the 13 and the 14.
You can.
That's how you put it in the
would?
calculator.
Yeah, you can.
Okay.
You know, it's a really good point, and that's this. Sometimes parentheses can overcomplicate things. It's okay. I tend to like to use times signs, right?
Yeah, but would it be like -2 times 13?
It would be subtract, not -2. Subtract. And you can go parentheses, parentheses, parentheses if you want to.
Okay.
Okay, yeah. Okay, 6.
All right.
Okay, the formula's still up here. You want to go from degrees to radians, right? We've got this formula. So if we want to go degrees to radians, it's right up here, right?
And then all of those will stay up there, right?
Yeah, that'll stay up there. Anything that's up there is going to stay up there. So I'm going to go 100 over 180 pi. And then I want to reduce this. I want it in terms of pi. I'm going to reduce this fraction.
5 eighths.
Yeah. It is going to be 10/18 pi, because I cancel the zeros, or 5/9 pi. Now, if you can't reduce, and there are kids that can't reduce, just can't. Some kids absolutely refuse to learn fractions. It's the way it is. You can use your calculator. Worst case, you go to 100 divided by 180. Go to math. There's a fraction button on your math. It's even highlighted. So it's saying take 180, 100 over 180, turn it into a fraction. Now we get the 5/9. Okay, so your calculator will reduce fractions for you. Okay. All right. 7. Okay, the formula's up here. We're going to go radian to a degree. We take 180 over pi times our radians. We're just going to use that. Okay, so I'm going to go ahead and take my 180 over pi times my 5 pi over 8. My pi's cancel. I like that. And I'm just going to take my calculator. I'm going to go 180 times 5 divided by 8. And I get an answer of 112.5 degrees.
Wait, Mr. Davis, can't you also just find, like, take the denominator of the 5 pi 8s and then figure out how many times it goes into 80?
Yes, we'll just leave it there, okay? Well said. It's easier for you. I like that. I am not going to teach that. How's that for an answer, okay?
Wait, what you said?
Say it again, Ellie.
If you take the denominator of 5 pi 8s and then figure out how many times it goes into 180, you can just find the numerator.
Right.
Oh. What? I'm
Oh,
Wait,
yeah, I see
what?
it now.
See, that's why I'm not going to teach
So
it
do
very well.
You do 180 divided by 8, which equals 22.5, and then you multiply it
By
by 5.
five.
Oh, yeah.
Oh,
yeah.
It's
yeah.
the same thing.
Same
It's a
thing.
fraction.
Yeah. Thanks, Ellie.
Yeah, 'cause this is, yeah, I see.
I tried it.
Oh, do I have a unit circle? Who borrowed my unit circle last?
Mr. Davis, don't mind.
Oh, I want this one. This is beautiful.
I think mine looks better, Mercedes.
Somebody borrowed mine, so I don't know where mine is, but thank you. This is nice. Okay, you ready? I bet Ruthie's is really good too. No, Kaylin? Okay, now sine. You guys ready? From the unit circle. Shh, shh, shh. Sine is the y value. 7 pi 6. 7 pi 6 is here. The y value is 7 pi 6 is here. The y value is negative 1/2. Okay, 7 pi 6 is here. The y value is negative 1/2.
7 pi 6 is 1 and 1.
Okay, cosine. Cosine is the x value. 3 pi halves is here. The x value is 0. Tangent is the outside. You see how Jade's got the outside stuff? So I'm going to go to 4 pi thirds, which is here. The tangent value is square root of 3. Thanks, Jade.
And that's why you need a unit circle.
Right. Okay, now, 11. I'm going to call it, I can call it one of 4 things. Now watch.
Sine.
So I can call it a sine and start here. See where I'm pointing? I can call it a sine and start here. I can call it an upside down cosine. I can call it a negative cosine, start here. I can call it a negative sine and start here.
Just
I
call
can
it
call
a
it
regular
a
sign.
positive cosine and start here.
Just call it a normal
Negative sign.
So we'll call it a negative. How about
No,
So-
Negative sign, bro.
all,
already there.
all 4 of those answers are correct. I'm just going to call it a sine, okay? We'll find it. All you're completely there are 4 ways, and I like the fact that you guys all solve 4 different ways. It's pretty cool. You learned some things, haven't you?
It makes your job harder.
Yeah, I just write all 4 down, look at it. Right? It does make my job harder, but it's okay. So I'm going to call it a sine. So if it's a sine, my midline. You guys see my midline?
Are you going to call it a negative sign or just sign?
Positive sign.
Plus 2.
Yeah. So I'm going to start there. So my amplitude is 2. So I'm going to go y equals 2 sine. You okay with that? And I can put down all 4 answers because I can do that. I know how to do it. 2 sine. Now b. B is called the frequency. And here's how you find b. B is 2 pi, always 2 pi, always 2 pi, divided by the curve width. Well, the curve width is
2, 2, 6, 4.
1, 2, 3, 4. I believe the
10.
curve.
Pi halves.
There's 1, 2, 3,
Start from
4.
10.
I believe it's 4.
So it's pi halves.
Yeah, so B is pi over
Oh, wait.
2, right? Parentheses x. Now I chose to call it a sine. So I started at 2.
Minus 2.
So I go minus 2. The midline, the entire curve got bumped up 3.
2, 3.
There's one answer. Or y could be a negative 2 sine of pi halves x plus 3. If I choose to call it a negative sign, then there's no horizontal shift, right? Okay, and that's probably what I would have called it originally.
That's what I was.
Yeah, that's probably what I would really call it. If I want to call it a cosine, anybody want to call it a cosine?
Yes, cosines are better.
Y equals 2 cosine pi over 2 x
It would give you
minus
like,
3.
all 4 answers on the test. Do we get extra credit?
No, but that would give you a big smiley face. And then, Ellie, that's it as a cosine, okay? So I bumped it 3, right?
Why couldn't you start it as a negative cosine and start it at
See, I'm
0?
gonna do all
Give us a
5.
hit on the bonus.
No, the negative cosine starts here.
And then I get an F on the test.
Oh,
Okay.
it was have to start at 12.
Okay, ready for 12?
I see what you're saying.
12. Almost done. So, x squared plus y squared minus 6x plus 10y plus 4 equals 0. Okay? Aiden?
No, the, like.
Oh, yeah.
I have one. Oh, thanks.
So here we go. It's a circle. X's with X's. Y's with Y's. Bring over the 4. Right? X with X's. Y's with Y's. Bring over the 4. Okay? Now, we're going to take 1/2 of b and square it.
Can you move it just a little bit?
Yeah. 1/2 of b, we're going to square, okay? So, negative 6. Half of negative 6 is negative 3. Negative 3 squared is a positive 9. Took half of this, ready? Half of this.
You take half a b and then square it.
Okay, Ellie? Half of this is negative 3.
No, I get the math. I'm just.
Doesn't go
Oh.
on.
Now, the reason why is this will factor. That's why we're doing it.
Okay.
We're making a problem that will factor, okay? Now, you ready? Watch. Watch. Everybody watching? I just added 9 to one side of the equation. What do I have to do?
I don't know.
Right. That makes sense. So don't forget to add 9. So plus 9, okay? Now, half of 10 is 5. 5 squared is 25. I just added 25 to one side, so I have better.
Add it to the other side.
Yeah, plus 25. Okay, now, Ellie, you asked a really good question. At first I didn't understand it because I wasn't listening well. But the reason we do it, because your why really is why would you do that? It makes a really nice problem to factor. It makes a really nice problem to factor because what we want is we want it in a certain form, right? So what happens by doing this process is we get an x minus 3 times an x minus 3 plus a y plus 5 equals, let's see, what is that? Negative.
30.
Is it 30?
Yep, it is.
Equals 30, okay? Now, we're going to get an x minus 3 squared plus a y plus 5 quantity squared equals 30. So, Ellie, that's why, because now it's in our standard form. So now we know the center, because we couldn't find any of this until we got it into standard form. So my center now we have as positive 3, negative 5. And the radius now is the square root of 30, which I don't know. Square root of 30. Hold on. Square root of 30. Or about 5.5, right? So we could graph it now. And that's why we do that. Craziness. So it will factor. Okay. Okay, now, 13. I need some graph paper. I got one sheet left. That's all I need, right? Because we're at the end, right? So one's all I need. You got, okay, so number 13. I have f of x equals 2 square root x plus 4 minus 5. Okay, so I'm going to graph first the parent function. Okay? I'm going to graph first the parent function. You ready? What's the square root of 0?
0.
0.
If I go over 1, what's the square root of 1?
1.
If I go over, I'm going to go over 4. I'm going to go over 1, 2, 3, 4 because the square root of 4 is.
2.
And then I'm going to go over 9. 4, 5, 6, 7, 8, 9. Square root of 9 is. And then I keep going, keep going. But if I connect the dots, that's my parent function, right? What we're going to do with our parent function, though, is we're going to take and we're going to move this thing back. We're going to go left 4. We're going to go down 5, and then we're going to make it twice as tall, right? So let me move it first, okay? So I'm going to move it first. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay? So I'm going to move it to the left 4 and down 5. So I took its endpoint. I just took its endpoint and moved it
And then
back.
instead of going 1, 1, you go 2, 2, right?
Close. I'm going to go 1, 2.
Oh, yeah.
Because it's twice as tall. So really good. So here's what Leon said. From here, I'm going to go over 1. 1 squared is 1. Square root of 1 is 1, but I'm going to go twice as tall. I go over 1, 2, 3, 4. Square root of 4 is 2, but double that and I go to 4. I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3, but I double that height to 6. And my graph looks like this. Okay? Now, we're almost done. Domain. It starts at -4. It does not go back. It starts at -4 and goes forward. So the domain is x is greater than or equal to -4. The range. It starts at a height of -5 and goes up. It does not go down. It starts at a height of -5 and goes up. Y is greater than or equal to -5. Okay? Last but not least. Okay? All right. Solve for x. I got log of 2x plus log of x minus 5 equals 2, right? This might be the extra credit. Or one like this. Do you want to see it?
Yeah.
Yes.
So if it's plus, we bring them together as times. I'm going to write this as log of 2x times x minus 5 equals 2.
Oh, I remember this.
There's an invisible base. What's my invisible base?
E.
10.
My bad.
So we're going to change it from log form to exponential form. You okay with that? So I'm going to rewrite this as 10 to the 2 power equals 2x times x minus 5. Okay?
Wait, why is it 10 to the 2 power?
We're going to go
It's that rule.
10 to the 2 equals what's inside, or
Oh, okay, yes.
it's the base to the exponent equals the answer. Okay?
Yeah.
Right? So now it's just algebra. 100 equals 2x squared minus 10x, right? Bring over my 100. 0 equals 2x squared minus 10x minus 100, okay? I got a factor, but before I factor, let's make it easier. Can I divide everything by 2, right?
Yeah.
Makes it easier. Divide everything by 2, just makes it easier. 0 equals x squared minus 5x minus 50, okay? 5 and 10?
Yes.
5 and 10, you guys agree? 5 and 10?
Yes.
So parentheses, 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 x minus 10 plus 5, right?
Yep.
My answers are x equals 10 or x equals -5, but not -5. Logarithms cannot be negative, so we throw that one away and we get 10. What do you think?